Right, I'll need to change my project over to the one we were on last, which was practice task 3 with this group. Yesterday the other group managed to get all the way to practice task 5, so they started working on that one. So hopefully we'll get even farther with you today, so that we can sort of beat them. So we'll open up both the parts file first. Just always takes a while with the first one. There. Just flip it around a bit to get to show it. Something like that. There. Then we'll also open up the drawing that we started creating last time. And we had gotten as far as putting in a section view last time. So now we'll start off by creating some center marks. So we'll go over to the annotate part of the toolbar. We'll start off by using the one called centerline bisector, which puts a center line between two lines. So we're going to use this one in the section view on the holes on the sides here. So I mark the edges of this hole and get a center line through it, and then I mark the edges of the other hole and get a center line through it. The problem now is if I do the same in the middle one here, I'm not going to get a center line all the way through because I don't have lines going all the way through. So there I'll use the irregular centerline function instead, the one up here. And I'll click on the top and then click on the bottom and then right click and create, because then I get a proper centerline through that one also. Then I'll start placing center marks in the base view. So I'll place one from on the top curve here, just to get a center mark going over for that one, to show where the center is. And I do the same for the bottom curve. And then I also do it for the largest circle in the center, just to get it fully formed there. And then I go over to the side and I create the center mark for the external edge and then also for the hole afterwards. So just in case that we later on won't go in here and remove the section view in order to rearrange the drawing in some other way. So just to make sure that we will always have a symmetry line going through the middle of the parts, we are going to place a symmetry line here. It's going to be covered over by the section line, but just in case that we're going to edit it at a later point, we still put in this one. So you can just barely see it below the section line. But the point is that if we remove the section, it's going to still be there. Then we can start placing dimensions. And now we're pretty fortunate because we have loads of symmetry and stuff here that we can utilize when we are putting in our dimensions. One thing I think I'll start off with is the holes in the section view. And I would like to place those dimensions up top, just to make them a bit more viewable with regards to the counterbore and stuff. So I'll replace the AA note. I'll drag that below the section view here. So I'm going to mark it and pull it beneath. Then I'm going to use the hole and thread node function. So I click on the hole, I change the formatting to method 1D, Now if I want to, I can press a quantity note on the 20 millimeter hole, or I can just write typical behind it. Or in this case, with only 2 of them, I might as well just place the dimension also. Doesn't really matter. So for the side holes, they're pretty easy. It's 20 millimeter diameter and they're going through. For the center hole, there is a counterbore, so it's going to look a bit different. Then we'll stop by here for a while.
You have open project. But
Three.
Yeah.
Yeah, I use this one for full length thread. Oh, in the center mark. These you could use just that one for all of them.
you can rotate this
There.
box and get the problem
There. So whether you just take the line or the green, but now you have to click your right mouse button and then create. And then you can start creating for the new one. Now you can set the mark instead. Let's see. You have to switch to the F1.
You really have to make projects on the track. You only made one project and it's project 4, so this will not be inside.
And then
You know how to do the rest of it?
the reason is that if you have sort of a pattern of holes, then you can go in a circle. You can create center lines on each hole. So curve around the hole in the circle. So that's why it sort of doesn't stop because you have to right click and yes, then they will put on and then I just switch it to 1 week, and then I get this benefit. Yeah, use the whole
Just leave that 20%
And you
do that.
can
So the next time you do it, it's the only one you have to
you
and remember to change the format to method 1B.
Usually just comes up.
You can add this line.
Space.
The last one you can annotate and afterwards use the whole
Yeah, so when we've gotten the put the hole and thread dimensioning on the center hole here, we see that we get some extra marks on it. So this sort of rectangle without a top, that is to show that it's the dimension of the counterbore, and it has a diameter of 40 millimeters. And then you have the downwards arrow, which shows the depth of this counterbore, which is 5 millimeters. So this is a better way of putting it in than putting all of the dimension lines regularly inside there, because then we would need to have a dimension line for the, we could actually do it just to show you. We would need to have the 40, we would need to have the height, and we would need to have the 20. So instead of placing 3 different dimensions in there, we can do everything with just one note, which makes it easier to read when we are reading the drawing afterwards. Then we'll start placing length dimensions. So I mark the dimension function, and I change the formatting to method 1B, straight off. And then I can give the distance between the center of this hole and to the center of this hole. And on the drawing for this task, we also have a special tolerance for that one. So when I place this one, I'm not going to click away from this window straight away.
The only reason why I'm getting this is the other thing is because you made an extraction of the string using the whole function. If you use the whole function, then it would. Yeah, no, put the whole function in the drawing. You made this as a 3D drawing.
No.
Here, this one, this is an extrusion. So if we just press this, and let's see.
And afterwards use the anti-bar. Transfer with it. Zero. And hold. And use the simple line function.
Right, we're going to put a special tolerance on this dimension, which means that we go to the tab which says precision and tolerance for it. And here we can set quite a few different tolerances for this particular dimension. So we have the default one, which is the one that's always automatically chosen. That's just a regular dimension. You have the possibility of using the reference option also, which will add a parenthesis around your dimension, which means that it is only meant for guidance. It is not a measurement that really needs to be taken into account when creating it. It's just to make it a bit easier for whoever's reading the drawing to read it. And this, you have to use this if you're giving the same dimension in two places. So if I give the distance between the center of these holes, both on the base view and up on the section view, I will have to have the parenthesis on one of them. The next we can choose here is the symmetric one. And now we can add a dimension over here, and it's going to become a plus-minus dimension. So if I, for an example, put in 0.2 there, and then I click away from it, let's see. Then we can actually see down here on my dimension, I've got 180 plus minus 0.2 millimeters. So when they are producing this, they are allowed to have a deviation from the 180 measurement with 0.2 millimeters, both over and below 180. So it might be 179.8 and it might be 180.2 for this measurement. Anything in between those two would be good enough in this production. And this is all well and good if your tolerance, if it's okay that your tolerance can go both above and below the dimension you have set. But if you need it to go only below or only above, or maybe not symmetrically, then you can use the next one, which is called deviation. And then you can actually add an upper and a lower limit to it. You can also change the sign in front of it from negative to positive, or from positive to negative if you want to. So if I want to, I can get both signs to become negative. And I can have both positive. Or I can have one negative and one positive if I want that one also. So in this case, what it says now is that this one can only be between 180 millimeters and 180.2. So it can only be in between there. Then you also have a couple of others down here. different ways of showing them. But then we get to the one that's called max. And this one will use your general tolerance. So the general tolerance that you give in your note down here is always a symmetrical one. It's always a plus-minus tolerance that's given in the general one. But if you use a max one, it means that your measurement is going to be a maximum of 180, but it's still going to keep on to the range of the general tolerance. So if you had plus minus 0.2, which is a total range of 0.4, so minus 0.2 plus 0.2, so you get a total of 0.4. That means that if you put in the max there, the measurement can be a maximum of 180, but it can also be 0.4 millimeters smaller. So you're telling them to use the maximum there, but they still get the range of the general tolerance. The same goes for minimum, only the other way around. Now it's a minimum of 180, but they still have the range of the general tolerance to move on. Then if we continue a bit further down, you also have the possibility of giving ISO fits for holes and shafts. So if we use this one where it actually shows the tolerance, we can choose, if we have a hole and we want an H7 ISO fit on the hole, we can choose an H7 in the drop-down menu there. And it's also going to show us what the tolerance is going to be in millimeters. And for the ISO fits, they usually have 3 digits. So point and then 3 digits. And then it can be wise to do the primary tolerance part up here and set it to show 3 digits. Because now, let's see. Well, an H7 is exactly 0.4, I can see. There. An H8, as we can see, it has 3 digits. If I now take this one back to just showing 2 digits, it has suddenly changed my tolerance there. So it's always wise to show all 3 digits when you are doing those ISO fits. But those are we're not actually going to use any of these tolerances in this course, but it's to show you that they exist. There is an easier way than sitting with your metal trades handbook and looking up the tables to figure out what kind of tolerance you're going to use. You can actually set them directly in Inventor and get them printed on your drawing. So it is a very nice way of just checking what the tolerance is going to be. On this drawing, we want a symmetrical one, and it's going to be 0.2. So now I put it up to 0.2, and then I click OK. So then I have 180 plus minus 0.2. Because later on, when we're putting the general tolerance note in, we're going to use a medium tolerance. And if I remember correctly, for this dimension range, that is plus minus 0.3 or 35. I'm not quite sure which one it is, but it is more than 0.2 at least. Now we need to give a few more dimensions. We need to know the radius of this curve. So we put in an R40. If you want to make real sure, you could put in typical behind it, just to make sure that this one is also going to be read as R40. But we do have a symmetry line going across here. So if this one is R40, that one also has to be R40 due to the symmetry line. So it shouldn't be necessary to put in typical. The same goes for the curve on the edge here. We put in R20 there, and it's symmetrical across the center, so it shouldn't be necessary to put in typical or a dimension on the other side. Then one more thing that we can do, just to make it a bit easier to read the drawing for whoever's going to create it, is to give the total length. I missed it there. Let's see. use method 1b when you're setting this one. So we give the total length like this, but then we have to make sure that we choose the reference option on the tolerances. Because this total length has already been given by 180 and the radius of 20 on both sides. So we already know that the total length is going to be 180 plus 20 plus 20, which is 220. But we often put in the total dimension just to make it really easy for whoever is going to create this part to go into their warehouse, for an example, and find the plate that fits and the total dimensions of what they're going to cut out of it. So that they don't have to sit down and do math in their head or use a calculator or anything, and they just get the total dimension just to see it right away. Then we can put in a parts list to get the material of the part. So we click the parts list option up top there. And then we select one of our views. And we place the parts list down in the corner. Then we double click the parts list. So we're going to start editing it. And remember that if you can't remember where you're going to click, which buttons to click in here when you're going to edit your parts list, it is always a possibility to just let your mouse hover above it. Then you will see a tooltip. So in this case, we're going to use the table layout first off, because here we can remove the title. So later on in practice tasks 7 and 8, we're actually going to do assemblies with several parts. So then we're going to have a proper parts list in our assembly drawings. But for now, for single parts, we don't need this title of parts list in it. And then we go to the column chooser. We remove the default properties. And then we find the material property and add that one. One thing I just want to mention here is that sometimes, especially if you're working for a company, they often want you to add the one above here also, the one named mass, because they really want to know how much this part is going to weigh. They want that to be written on their drawing. And what Inventor does then is that as soon as you have set the material in your parts file, it also knows the density. And since you've created a 3D model of it, it also knows the volume. And since it knows volume and density, it calculates the mass automatically. So, and it will also fix this mass if you change your 3D model so that you change the volume, or if you change the material, it's going to automatically fix this mass. So that is something many companies like to have, especially like for the oil business. If it's a small part, it might be that they're going to ship it by helicopter. If it's a really urgent stuff, they might ship it by helicopter out to a rig. And then you really want to know exactly the weight of it. But for all shipping, you usually need to know the weight of the object that you're going to ship, because as soon as it weighs more than a couple of kilograms, it usually costs per kilogram. So it's nice to know how much you're going to pay beforehand. But for now, we're just using the material, because it's the material that we are interested in here. So we click OK. We get the material column up there, and OK once more. So if you want to, you can just leave it like this with stainless steel on 2 lines. I don't like to look at it like that. I like to look at it in 1 line. So I just expand my column there so that I get it all in 1 line. Seems like I missed the corner here. There. Then we'll do the notes with the general tolerances and surface finish. So I use the text function up top there. Place it approximately where I want it. And I write in general tolerances and surface finish. We use ISO 2768-1. In this case, we wanted a medium tolerance, so M, lowercase m for medium. And then ISO 2768-2. We want the equivalent of the medium there, so that's a capital K. These designations you will find in the technical drawing part of the Metal Trades Handbook that you've gotten. So if you're ever wondering what to put, for an example, on this submission, a lot of these submissions had just figured out that they wouldn't put anything in there since it didn't say anything about general tolerances in the task itself. But you should always put them in. So I've written on most of them that it would be nice to see the general tolerances. And if you are unsure on what to put there, it is always nice to use the medium one. That's just my general tip for you. If you are unsure of what tolerances to use the medium one, because usually a machining shop will deliver something better than a medium one when they're just running their regular production cycle. Their machines are good enough to deliver something better than medium. So a medium is always a fairly safe bet, unless you have specific tolerances, like in this one we had plus minus 0.2 on the length dimension. So the mediums are always nice to use. And then we'll place the surface finish symbol. And in this one, remember to do left mouse button and then right mouse button and continue. Here there is no doubt at all that whoever is going to manufacture this one, they have to remove material. Because they have to cut the plate and they also have to drill these holes. So we're going to put up that they need to...
Excuse me?
Yeah?
From surface.
Yeah, the surface symbol up there.
Yeah.
Yeah.
Next. From
Yeah.
the surface, then where?
Then you place it down here.
Okay.
So down on top of the title. So removal of material is required on this one. If we put in this one, if we choose this, which is removal of material prohibited, then whoever is going to produce this one is going to come back to us and say, are you crazy? We can't produce this one without removing any material. So they're just going to think you're a really stupid engineer if you do that. So use the one that makes the most sense, which is in this case to remove material, because they have to remove material in order to make it. And we're going to put in RA 6.3. And RA is for the mean height of these ridges, which are created in the surface.
Click in here on the line, click, right click, the first ones, and the other.
And this is a very typical surface roughness. So, if like in the submission, you don't know anything about the general tolerances or surface finish, I would advise to choose the medium tolerances and choose this surface finish, the 6.31. If you have a smaller number here, so a finer surface finish, it means that the machining shop will have to run their machines slower in order to manage to create such a fine surface. But with 6.3, they can usually run at they can use their normal, regular production speed. And that is usually good enough. Unless, for an example, you're creating something where you need a sealing surface, like inside a hydraulic piston or something like that, where you need an extra fine surface where you're going to seal it. Then you will need something finer than this. 3.2 as a good example of something nicer. Usually, you will then be working from a product catalog from a manufacturer of seals, and they are going to specify what surface finish you need. So, but often it's 3.2, especially for O-rings and stuff like that. So. Then we need one more note. We need to add the break sharp edges note for this one. So we use the text function up there again, and we place a new text box. We write in notes and break sharp edges. 0.2 by 45 degrees. Just so that no one's going to cut their fingers when they're handling this. I have handled prototypes where just to save money they didn't add break sharp edges because it was just a prototype, and then you really needed thick gloves to work with it. You made lots of scratches in the gloves and you almost cut through the gloves when you're working with it. So it really does have a lot to say using this one. And the last thing for this drawing is to fill in the title field. So we go into the ISO part of the browser here. We open the field text and we edit it. And just to remind you, I would advise to pull this window more open so that you can see all of the lines. And then place the properties window beside it so that you get to see everything. The properties windows is this button up here.
Sorry? You press then you press the ISO. Why do you another field text. You add this, so if you just fill it out now. Usually pull it down so you can see all this and you need to fill out. So this is empty, this is empty, these are empty, this is empty. You need to fill them. So press this, and you need to find, for example, a company, you need to find it here it says company. So this is this one, and you have to go to projects, save this, and look to where these are. Okay?
So we need to go through all of the tabs up here and try to find these lines in them so that in this summary tab up top here, we can see that we have the first line is title, and that's also the first line that we're supposed to fill in, is also named title. So if I write mount in this one, and I click the OK button just to show you, when I click the OK button now, it also says mount on title there. So that's a good way of just checking that you have hit the right spot when you're editing here. So then I open the properties again, and now I can go through all of the tabs and just figure out where to put everything. Author, it's not the next one over here, but it is there. So author, I want to put that one in. In my case, I usually have to fix it because it has my initials in it since I'm logging in with my my employee account, which is my initials. But if I had been logging in with my student's account, then I would have been automatically placed as my student number here. And it is the student number that you're going to use on your submission. So then you add the company. Whether it is a fictitious company or you just write the name of the school, doesn't matter. Then we go to the project part. If you have previously saved your drawing, then part number is going to be filled in with the name of the file name of the drawing. If you haven't saved it, you're going to have to write it in now. And we saved this one last week, so it's already filled in. So then we go down to revision number. We need that one also in here. We have it all the way down here. So most of you in the submission used a letter or a number on it. Some of you used a decimal number, so 0 point something. I would advise against using that, because the norm is to use a whole number or a letter. So I would advise to use that on your submissions also, just to get used to how the systems work. Then we continue on to the status tab. And here we're going to fill out checked by, which will be one of your fellow students or something like that. In my case, I use Torbjörn. And I use Einar as the approver. For your submissions, I would advise you to go together with your either 2 other of your fellow students or maybe the team that you're working in for the project, and just check each other's drawings. Actually check them also. Don't just write their names in, but actually look at each other's drawings, because you can gain a lot of experience from that. That is part of the job of an engineer doing technical drawings, is to check other people's drawings and look for mistakes. So it's good training for you. And then we mark the approval date for it, because that one is also going to show here. So when I click OK, I can just double check here that all of the lines have been filled in, so that I've got all of the information. And then I click OK. Then I'll click the save button just to make sure that I've saved everything I've done, because now we're finished with this drawing. We're going to move on to the next practice task and start on that one. But before we do so, I just want to give a little heads up to you with regards to submission 2 and 3, because I discovered in submission 1 that some of you had chosen to copy someone else's file and put your name on it. And that is something that I can discover because you are giving me all of your files, and I can go into the properties and look at them. And if they are telling me the exact same thing, then I know that you've just copied a file. So for this submission, I've chosen to overlook it for the first one. But for the next submissions, that is going to be an instant fail if I discover anyone copying each other's files. It is completely okay to sit next to each other and create identical drawings, because if I feel that the drawings are too similar, I'm going to check the original files, but then I'm actually going to see that they are two individual files. They're not identical. So it's going to be easy for me to know who has actually copied the files and who has just done the same things while they have looked at each other and helped each other creating drawings. So that's not a problem. So just so that you know that, it's going to be an instant fail for the next ones, but the ones that I discovered this one will have a free pass on the first. So then we'll close down these. Yeah, I think we'll do a 15-minute break before we start the next one, just to... Right, so just to do a repeat of the message I gave with regards to copying files in the submissions. If you're sitting a group and you're manually copying each other on the screen, that's not a problem, because you're still going to get different properties on your files, so that I can still distinguish the files from each other. It is if you are starting to copy the files, then I'm going to see that they are basically the exact same file. So it's completely fine to sit together in a group and create practically identical drawings. That's not a problem. Right, we're going on with practice task 4, which is this one. So we're going to create a new project. and then the part file afterwards. So we open the projects window. I click a new project there. Select a single user project. Choose my folder in the H drive. And I'll create practice task 4B. And then we always have the problem with the new folder not being actually chosen, so we have to switch around a bit in order to get it. Click OK. I'll fill in the project name also. And once that is done, I can click Finish. And then I'm in on my new project here, practice task 4B. Ja, Åsmund, da er det Chigo. So then I'll click Done. And then I'll go to the New button. And again, we have to remember, since we're in a new project, it has reset us to the templates folder. We want to be in the metric one. We don't want inches. That's just for Yankees. So we choose a new part file, standard millimeter. And then we click Create. So first off, we'll create a new sketch. So start a new 2D sketch up in the corner there. As usual, I prefer to use the horizontal plane. And then Inventor flips my view 90 degrees. So I flip it back. And now we're going to create a rectangle, which is basically the outline of the part here. So the bottom of our part. But we don't want to use this rectangle option, because this rectangle option goes from one corner to the opposite corner of the rectangle. What I would like to do is to have the center point of the rectangle connected to the center point of my coordinate system. So then I use the drop-down menu, and I scroll down here and I see I can also create a rectangle using 3 points, 3 corners. And there I have a rectangle using the center point and then one of the corners. So that's the one I want to use. And if we just take a look at the tooltip here, we can actually see that it has numbered these. So number 1 and then number 2. And number 1 is the center point. So that's the first point that we are placing, is the center point. This tells us. So that we can just click it, and we know that the very first point is the center of the rectangle, so we can attach it to the center of the coordinate system. And I can just pull it out a bit just to get to see the rectangle. And now I want to put in the dimensions directly here. So instead of just placing the rectangle as it is and then manually placing dimensions on it, I can actually just fill in the dimensions straight away and get it to become the correct one. So I want to have mine placed like this, which means I need the longest dimension here. And the longest one is 90 millimeters. So I fill in 90 there. And then in order to get to the other one here, I click the Tab button on my keyboard, the one that is above caps lock. So I click the Tab button. And now you can see that Inventor has created a padlock beside the 90 millimeter dimension. And this means that it has locked it in place. So it's not going to change unless I manually go in there and change the numbers. So now I want to switch this one also, and it's supposed to be 60. And now you can see there isn't a padlock here on this one. So I have to actually press my tab button once more, and then I have a padlock on both of the dimensions. So now they are locked in place. And in order to place the rectangle now, I can either click my mouse button or I can push the enter button on my keyboard. Now we can also, if we want to, we can create the holes and the slot in the middle straight off, so that when we extrude, we're just going to extrude the plate and not the holes and slots. But we're not going to do that in this case, because what we want to do is to use the extrude function to cut through it afterwards. So for now, we're just going to extrude this as a solid plate. So we're going to finish the sketch, and then use the extrude function up there. And this one is supposed to be 15 millimeters thick. So 15. Then click enter. But before we start placing the holes and the slot in the middle, we're just going to create these edges, just so that we have them in place. So we'll create a new sketch. We'll place it on top here. And then again, Inventor flips mine. I don't want it this way, so I flip it 90 degrees to get it that way. Now, in order to help us a bit, it would be nice if we could have some lines that show the outline of the original plate. And we can actually get that, because we can use the project geometry option up here. So we click on this one, and then we just click on the flat of our plate here. And then we have yellow lines going around the plate, and we've also gotten a yellow dot in the center, which is very nice to have. And these yellow lines will function just as regular construction lines when you're going to extrude. So you can leave those in to fill in your extrusions. So what we want to do now is to create a rectangle on each side here. But then we don't want to place the center point. That's going to create a bit of trouble for us. Now we want the original one, where we go from one corner and to the opposite corner. So I use the drop-down menu, and then I choose rectangle 2 point. Then I go to one corner of my plate. I attach the first corner of my new rectangle there, and I pull it all the way down until I get this mark on the lower one. This means that it's going to constrain this point to the lower line of my plate. But I also need to have it at a certain width, and it's going to be 15 millimeters wide. So I put in 15 on that one, and I still don't have a padlock here, so I'm going to press the tab button. So I have a padlock there. I don't need to do anything with this dimension, because I have this mark that shows that I'm going to connect it to the lower line. So just by pressing the enter or left click on my mouse button now, I've got this one in place, and you can see that my lines are dark blue, so that it's all been locked into place. I do the same on the opposite side. Attach the rectangle to the upper corner, pull it down to the lower line, set the width of the rectangle, lock it into place, and then I press enter. Once this is done, just to be sure that everything is locked into place here, I exit the rectangle function, and I just check down in the corner here that it says fully constrained. So it says fully constrained down there. This means that I'm going to have no problems with my extrude or anything. So once this is done, I finish my sketch. I click on the extrude option. I just zoom out a bit so that it's easier to see everything. And now I'm going to choose both of these rectangles that I created. So first I choose that one, and I choose that one. And just to show you what happens if you accidentally press in the middle here, you're going to get a full plate. But if you do that, you don't need to press cancel and start all over again. Just hold down the control button on your keyboard, and then you mark the middle part again, because then you're going to demark it, so that that's not a part of your profile anymore. So in this case, we are going to have a total height of 30, which means that we are going 15 more up. But if you are unsure, in this case it's easy to do the maths in your head, but if you are unsure, just write the equation in there. So in this case it's 30 minus 15, and then we know we get the correct one.
You have a big problem here. So the sketch goes down here. Okay,
So then we've gotten these edges on, and we'll just give everyone a chance to catch up before we do the holes and the slot in the middle.
when we're in this sketch, we want the rectangles to be on it, right? Okay, look at this part, right? So when we do the rectangle, do this, we want to put the side here, down to here, not down here, on it. So then you see it snaps and it says 60. So we only want to do this, 50. Then you have it. So do the other side. So it doesn't matter which corner, just one. Click it. Yeah, pull down. Make sure that you're on the line. It says 60. Perfect. Just leave it. So leave the mouse. Press 50. When you click enter now, it's 60 plus 50. Finish sketch. And then press extrude. So now you choose your area.
Right, we'll create a new sketch in the middle here. So I start a new 2D sketch, and I click on the middle section of my bracket. I'll just tilt it back into the direction I prefer to work in. And as you can see now we are looking at it from above. So we are looking at it straight on here. We can see these edges and everything. But now there are a couple of things that we can actually do. In this case, it's not a problem that we can see these edges. They're not in our way or anything. But you might end up having overlap here, so that some parts that we're extruding out here in your part will cover the place where you are supposed to create a sketch. So one thing you can do is, instead of using project geometry there, we can use the drop-down menu and choose project cut edges. And that means that this plane that we have placed, the sketch that we have placed it on this surface, which means that the sketch is actually cutting through the edges here. So when we choose project cut edges, it's going to show the edges of everything that is being cut through of this sketch. And also, to give us an even better view here, we can click the F7 button on our keyboard. So F7. Then it's going to remove everything that is above the sketch. So it removes all of the material that is above, so that we get to see the exact plane, just as if we had put this part into a saw and we had just cut it along cut off these edges on it. If you can't remember which button to use, that you're going to use the F7 to do this, if you need to do it, then I would advise you to go to the View tab up there on the toolbars. And then you have the one that's called Slice Graphics. And you can actually see they put in F7 in a parenthesis on the tool tip there. So then you just slice through it in order to see what's on the plane you're working on. So we'll go back to our sketch. There it is. Click the wrong one. And now we can start placing holes and the slot. So in earlier versions of Inventor, I think it's from 2014 and back, you didn't have a direct slot option. You had to choose a rectangle and then you had to fillet the edges in order to get a slot. But from 2015 and on, you got this extra function in the rectangle drop-down menu, which is actually directly creating slots for you. So that's a nice way to do this one. What we want to do is to create a slot that is exactly centered in our sketch. So it would be nice to use our center point. And again, we can see here, the first point that we're going to place is the center point. The second point is the end of the line between the centers of these filleted edges. And then the third point will be the width of the slot. So we choose this one. First point was the center point, so we attach it to the center of our sketch. We pull it directly upwards. We make sure that we have this horizontal, this vertical constraint mark there, because then we know that Inventor is going to automatically lock this one in to become vertical. And we want to set the length of this one. And the total length is going to be 30. But we are starting off from the center and going to one side, so we do 30 divided by 2. So then we get half the length for ours. Again, I haven't locked it in place, so just to be sure, I can press my tab button just to get the padlock in place there, and then it actually shows the dimension of it. 30 divided by 2. Yeah. You can also write 15 directly. It's not a problem. So it's just if in this case it was an easy thing to do the maths, but sometimes you can have like quite a lot of dimensions you have to take into account, and then it's easier to just write in the math equation instead of.
But now we can write 15.
Yeah, it's going to be 15 anyway, so you can write 15 directly if you want to. Then you get the padlock on, and you can press enter. So now we've set the center point, we've set the top point, and now we need to set the width. And we don't actually need to move our mouse or anything here now. We can just write in that it's going to be, it's going to have a radius of 5, which means that it needs to have a width of 10. So either write 2 times 5 or write 10 directly. As soon as we press enter, it gets locked into place there. Now this slot, we'll have to use an extrude in order to cut this slot anyway. But we could extrude this one and then use the hole function for the other 2 holes. But in this case, we're just going to use the extrude to cut everything in one go since we're doing this anyway. So I choose the circle function in order to create my holes. I'm going to place them approximately in the correct place. These are also going to have a diameter of 10. But as we can see now, it's green because it's not locked into place. The only thing that's locked on this one is the diameter of it. So the first thing I want to do is to lock it to the center point so that I get it exactly horizontal from the center point. So it's going to follow a horizontal line from the center point. So I go up to my constraints up here and I choose the one that's named a horizontal constraint. I click the center mark of my circle, and then I'm going to click the center of the sketch. And this means that no matter how I click and drag on my circle now, I can only move it sideways. I can't move it up and down anymore. So it's only going to move sideways. But now I also need to set the dimension between the center point and the center of my sketch. And I can either give that dimension from the center point to the hole, or I can give it from the edge here and to the hole.
That's a side
Yeah.
Second time. Okay. Then I would advise you to switch.
Yeah, that's the side brace.
No problem.
Write down the number of that one.
We know how to measure distance, but I can't see on the
Du
computer.
bara använda den här grafen till mig.
Nej.
How about distance?
Det står i
Står i kompendiet. Jag har inte kommit så långt än.
Okay. Yeah. Now you are showing.
Men var som gav den igen?
Det var som han kom tjej på.
Bare gi beskjed til IT at jeg tar en kikk på det.
Och den.
Hva er nummeren som er på siden?
037 kan det stemme? Er det det siste på nakken?
37. Hva var det som stod antall? PCU PC og STU?
PC og STU.
Skal vi se, den var grafikkproblem.
Ja.
Hva var det den var i går?
Du fikk ikke kontakt med hårddisken.
Nå har vi i hvert fall F og gitt beskjed, så får de sitte. Right. Then we'll continue by setting the dimension here between them. So according to the original drawing on the first page of the task in the compendium, we have 25 millimeters from the outer edge and to the center of the hole. So I put this one in and set 25 millimeters. And now my hole is locked into place. Now everything is dark blue or purple or whatever color it is. Now we need to create the other hole, but instead of doing all of this process again, creating a 10 millimeter hole, locking it into place with dimensions and everything like this, we actually have the center line of the slot and we can use that as a mirror line. So we'll just use the mirror function up on the pattern part of the toolbar. We'll select the circle and we'll select the center line going through the slot as the mirror line and we'll click apply. So then we've got everything in place. We click finish sketch and I'll just rotate it a bit so that we can get to see it a bit better. And then we'll use our extrude. And in this case, just wait a bit so we get everyone with us here. It's locked into place now. It also says fully straight, so you can move it. So then you just need to do the if you click on the sketch there.
Where's the
Yeah, you're on the sketch now. You need to use the mirror function. It's to mirror this hole across the center line there. Yeah, it's not a problem. But whether you do the distance from there to there, that's not a problem. Yeah, that one has mirror line. Yeah. Select on the circle. And then you click back. If you click down, it doesn't work. That's the, I think that's the Right, so in this case, we want to cut instead of add material. So the top option here is to add material, and the middle one is to cut. So we're going to choose the cut one, and we have to select the profiles of our circles here and the slot. So we select those. And if we are unsure about the depth, here it says it's already pre-made for 15, so it's going to go all the way through. But if we are unsure, we can use the extend option up here, and we can choose all. Because then it's going to cut through all material that's in a direct path. The problem there is that if you have a really large part, and maybe you have something coming around down here, then it's going to cut all the way through everything. So if you use this all, you have to make very sure that there's nothing in the way down here where it can cut through. And we click OK, and we've got the slots into place. Now we only need to set the material before we start creating the drawing. So we go up to the material menu up here. We open the drop-down one, and this one was supposed to be austenitic stainless steel. So we scroll down to stainless steel, and then we find the one that's named austenitic, and we select it. So before we start creating the drawing, we'll have to save anyway, because Inventor requires us to save the part file before we can use it as a base view in the drawing. And this one we'll just call bracket. So then I'll go up to the corner there and click the new button. And now I need to scroll down until I get the ISO.idw in place. Then I click create. So I get my new drawing in here, and I'm going to place the base view. And I don't want to look at it this way. That's not going to help me much. So I need to rotate it a bit. Also, what I would like to do is to show it actually this way in the drawing, and I would like to make a section view going through both of the holes and the slot in order to show those properly. So I rotate it 90 degrees, up like that. And also it looks a bit small in my drawing, so I'm going to try to increase the scale to 2:1, and that looks a bit better. So I'll click OK. I'll drag the view a bit over to the side here so that we have enough room for a section view here. And then we'll create a section view going straight through the middle of the part. So the way we attach it to the center of the part is to make sure that we get this green dot to begin with. I'll just go and help someone out. Oh. Chemicals. Just wait a bit so we get everyone with us. So then with new drawing, and then it's base view drawing. And then you'll need to use this cube in order to rotate. So get it to face the way you want it to face. Yeah, I would have flipped it 180 degrees more, just to get these edges, because we're looking at the back side of it. So if you keep pressing that one, and then once more, now you can see the edges here. Yeah.
So what's next?
Then increase the scale, 2 to 1. So you can just use the drop down. Choices. Yeah. Just drop down and then 2 to 1. And probably flip it this way, since we're creating the section view. It will be better if we have it like that. Right. So if you go to this one again, then you just flip it on the corner. Yeah. Then you get that. Because then when we create a section view here, we can place it on this side.
Du har lagt den i 12 mål. Jeg tror du kan skalere den med å så endre alle parametrene på en gang.
Du kan skriva millimeter
You
når du...
can go into each of the dimensions, and you can write the number in millimeters, and then actually press millimeter behind. So you can put two lowercase m's behind the dimension. It's going to put it in millimeters. But the problem is, as soon as you're trying to do your drawing, it's going to give out the dimensions in inches. Yeah, so you can work around it in your 3D parts by telling it to use millimeters instead of inches. But as soon as you go into your dimensions into place in the drawing, it's going to show you in inches. So I'm not quite sure if you can work around it in the drawing. Okay, so placing the section view, I have made sure that my mouse pointer has found the green center point of the top line. So I pull it a bit upwards, and I get this dotted line following my mouse pointer, which tells me that I'm still vertically above that center point. So I click once to start my section line. I pull it straight downwards. It's pretty easy to see. If you haven't gotten it straight downwards, you will see that it is tilted like this. And when you've gotten it straight downwards, you will also get this symbol that it's at a 90-degree angle. So try to have approximately the same distance past the parts below it as you have above it. And then we place it. And now you see we could have placed more section lines if we wanted to here, in order to section it in several planes if needed. But we're not going to do that on this one. So we'll click continue. And we'll place the section view over here. So then we'll need to go to the annotate toolbar to start setting center lines and dimensions. So we'll use the center line bisector in order to create center lines in the section view. We'll use the center mark function to create center marks on the holes and also on the edges of the slot.
Now it's in the middle, because now you have this normal.
So the center mark function here. On the holes and on the ends of the slot. And then again, we have a part where we have quite a lot of symmetry working for us. So we can use center lines to create symmetry lines on this one. And we want a horizontal symmetry line. And we also want a vertical one. It's going to be hidden by the section line, but we want it to be there just in case.
It's great.
Fant du måte?
Ja, jeg endret dokumentfilen til millimeter, og så gikk jeg inn i skrivemodellen, og så gikk jeg i det han er født, så det er klart det er 5 4 år, så da har jeg tegning i neste år. Det er det jeg har
Right, then we'll start placing dimensions. So we'll use the general dimension option, and we switch the formatting to method 1b. And the first one we'll place in is between the center points in the slot, so that we get the length of the slot. And as you can see, usually we like the number to be in the center of the dimension line, but in this case we have the section line going straight through there, so it's going to really make it difficult to read the number. So we place it a bit to the side, just to make it more readable. We'll also place the total width of the part. And since we have a symmetry line going horizontally through it, we can give the dimensions of the placement of the holes and also the edges here and the total height without a problem. So between the center marks of the holes, between these edges, and then all the way from top to bottom.
So you want from this edge to this line?
Then we'll also put in the height of the bracket. So the total height below here. And I'll put in the height difference up here, just to get this one shown also. Then for the slot here, I want to give the dimension between the sides of the slot. If I choose the line between here, it's going to give me a diameter, so it's going to put the diameter sign in front. But we don't want that, we just want the width of the slot. So this one to that one, and it gives us 10 millimeters. But on the hole above it, we can do the diameter dimension, so that we get the capital phi symbol in front of there. And then we can also do typical behind it, because that's going to give us both of our holes. And as we can see now, that becomes sort of a problem here, because we don't have enough space between our dimension lines. So we're going to just exit the dimension function completely, and then we're just going to drag the dimension so that we can get it to a different location and get it outside the dimension lines. The dragging of it? Yeah. We haven't done that before, so I can. It's not a problem showing it. So originally it was looking like this. So you got the dimension was sort of cutting into the dimension lines. So you have to make sure that you exit the dimension function. That can't be blue, because if you're inside the dimension function, if you have that one activated, you're only going to open up this window where you can set your tolerances and everything. So make sure you exit it completely. Then you hover your mouse button above it, and then you just click and drag in order to move it. And then depending on how you move your mouse, it's going to move in different ways. So if you just do it very slowly to begin with, then it's a bit easier to see where it's going to place it. And we'll try to finish this one off before we stop today, I think. We only have parts list, the general tolerances, notes, and the title field. So I'm just going to run through those. Use the parts list function. Select one of the views. Press OK. And place it in the corner. Then I double click it. I go into the table layout. Uncheck the title. And click OK. Then I go to the column chooser. Remove the default properties. Then I find the material one and add it. Click OK. And I apply it. And now I really need to change the width of my column, because now it's divided into 3 lines with the material here. So I'll use the text box function.
No, this is if you do from here.
Place this in here.
And if you here get the diameter. So we're this one. Okay.
And I put in general tolerances and surface finish.
We want it to say parentheses.
ISO 2768-1. And I think this one also was supposed to be medium.
No.
Medium. ISO 2768-2. Capital K.
Nothing is blue now. Okay. Then you click and hold. So click and hold. Pull down.
So I click OK and move it into place. Then I'll place the surface finish. Left click and then right click and continue.
Dotted line around.
We'll remove some material here, and we're going to put in 6.3 on this one also.
Same with the number, you can turn it out.
So RA 6.3. Then we'll put in the notes section for break sharp edges.
Remember, you made notes, and you did surface, hair, symbol, and then you did material. Same as the last one. Okay? Where's
So
your
break sharp edges 0.2 at a 45-degree angle.
Because when you make this, it's nice to have your because you actually look at the drawings, and that's what you're trying to make. You're not trying to only follow him, right? You're thinking by yourself, because you're going to make some drawings by yourself. So you want to end up.
Then we only need to fill in the title box.
Okay. So then you see what you do. This and this and this.
So we go over in the browser window,
Doesn't matter which.
find the ISO part.
Just you make this. So now you've done this, right?
We edit the field
Now
text,
you want to do this.
and we get this one open again.
So try and find out where you are. For example, this one.
So I'll put in the title. This one was bracket. Put in my student number, the company name. I haven't saved it yet, so I have to put in the part number also, the revision number, checker, approver, and approval date. So then we filled in everything. I just double check that all of the lines have been filled in. And okay. So then the drawing is complete. I just need to save it. So next week then we're going to start fresh on practice task 5.